Assalamualaikum and very good day to all of you. Okay, today we're going to continue our lesson in gas diffusion chapter for mass transfer. And for your information, we are in the last part of this chapter, which is part 3, where in this chapter we will learn about diffusion coefficient. Okay, if we can have a quick recall about our previous chapter, in which that we have learned how can we calculate the flux if there is a equimolar counter diffusion in part 1, and we also learned how can we calculate a flux when there is a mechanism what we call A diffusing through non-diffusing B. So in part 3 we will learn how can we calculate or determine the diffusion coefficient. So if you still remember this main formula for determine the flux, which is J, okay, in this two part, okay, in this part 1 and part 2, our intention is just to calculate the flux value, okay. And in this both of this case, the DAB value is given. DAV is given. Okay. But for part 3, is just to focus on how can we determine the diffusion coefficient. Okay. So the DAV is not given, so you have to calculate the DAB before we can calculate the J value. Alright? Okay, for the prediction of diffusivity, there are two methods available, which is the first one is Chapman and Escott method, and the second method called Fuller et al. Okay, so here is the formula to calculate the DAB using Chapman, and this one is the formula to calculate the DAB by using the Fuller et al. Okay, so for diploma level, we will use a lot on the Fuller method rather than Chapman and Escott method. Okay. So if you can see, we have a lots of parameter which is we are not familiar here, and I will explain to you in the next slide. Okay, let's start with the first method, which is Chapman and Escott method. So according to the formula here, we have quite many new parameters which is we are not familiar before, which is the P here actually represent the absolute pressure, must be in ATM unit, and sigma AB here represent the average collision diameter, and the last part here, which is actually the collision integral based on the Lennard-Jones potential. So I can say that these two things which is quite complicated to be determined. So that's why I said that in the diploma level we just focus on the method of Fuller et al., which I will show you in the next slide. Okay. Oh yeah, before I forget that the MA and AB here actually represent the molecular weight of gas A and gas B. Okay, let's take a look at the Fuller et al. Method. Okay, so we have the formula here, and there are two terms at the top there, which is MA and MB, which is represents the value the molecular weight of gas A and gas B. And what about the summation of VA and summation of VB here? So these two value is actually represents the atomic value, where you can get it from the textbook. Okay, from table 6.2.2, and the table look like this. Okay, so if you can take a look at the table here, okay, it consists of atomic and structural diffusion volume, and we have diffusion volume for simple molecules here. Okay, for example, we have gas A, which is methane, with the formula CH4. So how can we determine the value of VA here? Alright, so from stoichiometric equation here, we know that methane has 1C and 4H. Okay, so from the table here, we know that C is actually consists the value which is 16.5, and for hydrogen the value is 1.98 here. Okay, so we multiply with 4 and plus with the value from the carbon here, C. So there we are, we have the value of summation of VA. Right. So how about the VB value? Okay, let's say the VB value, we have two conditions here. Let's say our VB is our gas B is air. Alright, so for VB value, summation of VB, we can just directly get it from this table, where air is actually the component which is listed down here as part of the simple molecules value. Alright, now let's say if the let's say the gas B is not part of the component or molecule which is listed in here. For example, in case 2, we have gas B, which is in this case is propane. Yeah, with the formula C3H8. So how can we determine the VB? The same procedure that we use when we calculate the VA, we also use it in the VB part. So for example, propane has 3C and 8 hydrogen. So the C is still 16.5 and H still 1.98. So just include in the formula, and at the end you get the value of VB. Alright. Okay, let's start doing example related to diffusion coefficient using Fuller et al. Method. So based on the equation here, the equation asks you to determine the diffusivity coefficient for butanol, which is considered as gas A, diffusing through air, which is considered as gas B, at 1 atm using Fuller et al. Method. Okay, and you need to determine the diffusivity at 3 conditions. Okay, condition A at 0 degree C and the pressure is at 1 atm. For equation B at 25.9 degree C at 1 atm as well. But for equation B, you have to use the same temperature. For equation C, you have to use the same temperature as B, but the pressure is changed to 3 atm instead of 1 atm. Okay? Okay, let's plan how can we solve the question. Okay, so we know that we need to determine the diffusivity at these 3 conditions, condition A, B, and C. Okay, so in order to make things easier, I will draft it into this kind of a table. Okay, and then I will check with the equation. Okay, so we know that we have to use the Fuller et al. Method equation. Okay, this is the equation. So let's check the parameter which is contained in the equation here. Okay, so let's start with the t. Yes, we do have t value. Okay, at these three condition. And p, we have the p value here, which is p here. Okay, and for MA, the molecular weight of butanol, you can calculate it, okay, by using table. The same goes to MB, molecular weight of air. Okay, and for VA, atomic molar volume, for gas A and gas B, we can predict by using this table. Okay, okay, let's proceed with the next step, which is we need to determine the molecular weight of butanol and molecular weight of air. So since the value is not given, actually the value here is not given in the question, so we need to determine the value of molecular weight for butanol and air from periodic table. Here we have the periodic table. So the value that you should focus on here is actually the atomic mass, which is the value at the bottom part here. Okay, so for example, in this case, our gas A, which is butanol, with the formulas C4H10A, sorry, C4H10O. It consists of 4 atoms of carbon and 10 hydrogen and 1 oxygen. So let's take a look the value of C from the periodic table. Okay, the C here, which is 12.011. Okay, so I just take it as 12, okay, and multiply with 4. And hydrogen here, which is 1.0094, I take it as 1, okay, and multiply with 10 because it consists 10 hydrogen. And last one, which is oxygen, which is 15.99, which is I take it as 16. Okay, so at the end you get the 74.1, which is as the MA. Okay, so same procedure goes to air value in order to calculate the molecular weight of air. Okay, next step, which is we need to determine the value of atomic value. Okay, so I don't want you to be confused between atomic value and molecular weight. It is two different things, which is molecular weight symbols as MA, and atomic value, which is we need in the formula as summation of VA and summation of VB. Alright, so for atomic value, we need to refer to the table 6.22, okay, in order to get each atomic value. Alright, so for example, gas A with the formula C4H10O. Alright, so it consists 4C, 10 hydrogen and 1 oxygen. So the value for each atomic value is obtained from the table here. So as we can see, right, the carbon is 16.5 and hydrogen is 1.98 and oxygen is 5.48. So we multiply between these two values, okay, and at the end we get the summation of the value here, which is 91.28. Alright, so we got already the VA value. Now let's move to the gas B, in which in this case our gas B is considered as air. So the summation of VB, we can directly get it from the table here, because air is part of the listed value of a simple molecule here, okay, which is 20.1. There we are, we have the summation of B value. Okay, so from previous slide, we already know how to calculate the molecular weight A and molecular weight of B, okay, based on the table, okay, and we also already calculate the value of VA and VB from the previous step as well. So this is the VA and this is the VB value. And the next step is we want to substitute into the equation. Actually, from the equation we have three different conditions. So first we just focus on question A, where question A we have to determine the DAB at temperature 0 degree C or 273 Kelvin and at 1 atm. So since we already have all the needed value to be substituted into the equation, then we can substitute all the value into the equation in order to get the DAB value. So the T here is supposed to be the temperature inside here, and P here is supposed to be the temperature in here. Okay? Well, in order to substitute into the equation, I have some tips for you. Okay, in order to avoid confusion, I would rather arrange the equation into two different parts. Okay, so first of all, I will substitute all the value of 1 MA and MB term here, okay, which is in this term. Then I multiply this term with the T here. So let's say this is term alpha, okay, and I multiply with term beta. So these two term is being multiplied here. Okay, so here is alpha times beta. So I already got the terms on the top part. Okay, and then I solve the terms in the bottom part here. Maybe I call it as sigma term. Sorry, maybe I call it as x. Okay, so x is here. So therefore, to calculate the DAB, I just divide the top and divide by bottom part here. Okay, but up to you. If you want to just calculate directly, it's okay. Just that makes things easy for me to check again if I did some error during my calculation. Okay, so at the end I managed to get my DAB at 1 atm and 273 Kelvin is equal to 7.0 times 10 to the power of minus 6, and the unit is meter square per second. Okay? Okay, from previous slide, we already determined the DAB for condition listed in A, where the condition of DAB required for A is at 1 atm and temperature 273 Kelvin. Okay, so for condition needed in question B, which is at 1 atm and temperature 289. So if you notice here, for question B, it need to be determined at the same pressure, but different temperature compared to B. Okay. But for question C, it need to be determined at same temperature as question B, but different pressure, okay, compared to B. So you can see that the pressure is not the same. Okay, so in order to determine the condition listed in B and C, you don't need to recalculate it again. Okay, you can only use correlation between DAB temperature and pressure. So how can we get this correlation? So from the formula of Fuller et al., we know that the DAB is actually proportional to T to the power of 1.75, which is, this one is a temperature. So DAB is proportional to the temperature power of 1.75, and it is inversely proportional to pressure. Therefore, we can make this correlation. Okay? So if we have another second condition, for example, condition B, so we want to determine the DAB2 at condition B. Okay? So if you compare question A and question B, the difference only in terms of pressure. The difference only in terms of temperature. So the pressure has no difference. Okay? B and A, the pressure is the same, which is at 1 atm. So let's solve question B first. Okay? So how can we get the DAB? Okay, so after darab silang this equation, okay, we can get this term, which is DAB2 can be determined by using this equation. Okay, so let's start with equation B. Okay, so this is actually the value of DAB that I determined by using the equation that I showed to you, the equation of correlation between DAB, T, temperature and pressure that I showed you in the previous slide. So I will show it you one by one how can I get the answer for B and C. Now let's start with the B. How can I get this answer? Okay, so we are using this equation. Okay, we want to determine the DAB. So I consider that this is as condition 2. Okay, case 2. So I want to determine the DAB2, which is this one. How can I determine it? Okay, so I need to use this equation. Okay, so DAB1, which is the condition at 1. So condition 1 is actually condition that I already determined in question A. Okay, which is, this is the DAB1. In this case, DAB1 is actually 7.71, which is I already get in A here. Okay, and the T1, the T2, which is condition at T2. So in this case, question 2, the T2 is here. Okay, and this is my T1. Okay, this is for question B. Okay, for pressure, I didn't include it. Why I didn't include this term into my equation? This is because if you notice that the pressure for question A and question B is the same. So no point for me to put into the equation for a substitution. Then I can just simply calculate the DAB2 for question B by using this equation. Okay, so lastly, I managed to get this DAB, okay, for question B. Okay, let's move for question C. Okay, so for question C, if you compare question C, you can use correlation between B and C. Okay, so if before this we consider question B, condition at B is considered as condition at 2. Now, if you solve question C, this one considered at condition 2, and this one is actually considered at condition 1. Okay, so since from the question here, we know that temperature is the same. Okay, the only difference is pressure. So we don't need to substitute the value for temperature. Okay, but we just need to substitute the value for pressure. So this one considered as P2 and this one is considered as P1. So I substitute the value into equation here. Okay, same equation that I use for B, except that I exclude this term. Okay, so that's why if you see the equation that I use in C, the term for temperature is not there. I just use the term for pressure only. There's no term for temperature. However, for question B, there is a term for temperature. Okay, because this one I compare A to B, but for C I compare B to C. Okay, so at the end, however, for DAB1 here is actually DAB, which is I already determined in question B. Okay, so lastly, I managed to get the DAB for question C, which is this one. Alright, thank you. Okay, the end. I hope you understand the lesson. If you have any question, we can furtherly discuss during the forum session. See you again. Bye.